So we're going to spend a couple of days on adding and subtracting rational expressions. So what we did last time was simplifying expressions and multiplying, dividing. When you see a division, your goal is to do what? Change it to multiplication right away, okay? How do you change a division problem to a multiplication? Yeah, dividing by a fraction is the same as multiplying by its reciprocal, okay? The other thing we talked about were exclusions. Exclusions are where that rational expression is equal, the denominator would be set equal to. Exclusions are where the denominator would equal 0, which we cannot divide by 0. So those are our exclusions. If the exclusion, after you've done all your simplification, ends up in your final answer, we classify that exclusion as a what? Asymptote. If in the course of our simplification it went away, we'll say that that was a hole in the graph. So it's a place the domain does not exist. Okay? So let's go back to middle school. How do we add and subtract rational numbers? So how do we add 5 6 plus 4 ninths? In order to do this, we have to find a what? Common denominator. So we must find a common denominator. So all of that was fun when you did that. Another word for the common denominator is the least common multiple. Okay, so it's the smallest number that's 6 and 9, smallest number that is a multiple of 6 and 9. So the way we do this, what are the factors of 6? Yeah, so we'll skip the 1, but the prime factors 2 and 3. Okay, what are the factors of 9? 3 and 3. Okay. So I have to have, my denominator has to represent all of these factors. My denominator needs a 3. Excuse me. It needs a 2. It also needs a 3. Okay? So it's going to have both of these factors. Look over here. My denominator is going to have a 3. Well, good news. We already have one. Now, but not only is it going to have one 3, it's going to have how many? It's going to have 2 3s. Okay? So this tells me my denominator needs to have a 2 and a 3. This tells me my denominator needs to have 2 3s. So what is the common multiple or the common denominator here? 2 times 3, which is 18. Okay? So the common denominator here is 18. So you broke that down into each of its multiples, each of its factors, and then each factor has to be represented in your denominator. So what I will do, in order to add 5 6 and 4 ninths, I need the denominator to be 18, okay? What do I have to multiply 6 by to get an 18? Yeah, so I'm going to multiply this by 3 over 3. I'm not changing anything because what is that number? That number is 1. This one is going to be multiplied by what? 2 over 2, okay? When I do that, you'll see in both cases the denominator will be 18. So this will be 15 plus 8 over 18, which is what? 23 over 18, okay? So that was just the warm-up to say, remember how we did this back in the day, okay? You find a common denominator, and then you may have to multiply the fractions by 1 in different forms to get that common denominator. Then you can combine things by adding the numerators together. So let's figure this out. We're going to move, instead of using numbers, we're using rational expressions. I need to add 2 over x squared minus 4 to 3 over x plus 2. So the first step was to break the denominators down into their what? Starts with an F. Factors, okay? What are the factors of x squared minus 4? Yeah, that's x plus 2, x minus 2, okay? And then you look at the next one, x plus 2. What are the factors of x plus 2? This one's pretty easy. X plus 2, that's it, okay? So, my common denominator, it needs to have an x plus 2 and an x minus 2, okay? So this tells me both of those factors need to be in my denominator, okay? This tells me that what needs to be in my denominator? X plus 2. You're in luck because what? You already have one, okay? Very good. So what is the common denominator here? Your common denominator is x plus 2, x minus 2, okay? So the way you break it down into its factors, and you have to recognize each of these factors needs to be in my denominator. Each of these factors needs to be in my denominator. So if I have this as my denominator, I've got both of these factors, and I have this factor. Okay, that will cover the case of all factors being represented in the denominator. Was there a question? Well, once you've got it in fully factored form, then you say, okay, my denominator has to have every factor represented. Okay, so this tells me that my denominator needs these two factors. Okay, this tells me my denominator needs this factor. Okay, so well, if I write down both of these, I've covered both cases. Both of these are here, and this is here. Okay, so you have to have one represented. Now, if this had been x plus 2 times x plus 2, if there had been two of them, I would need to add one more in that case. That was just sort of like we did here. When we went back up to the numbers, I need a 2 and a 3 in my denominator. This says I need a 3 and a 3. Well, if I do 2 times 3, that gives me a 2, a 3, and I also have two 3's. Okay, so you have to pick at least one. You have to pick one of everything that is there in your factorization. So let's go back to this problem. My common denominator is going to be x plus 2, x minus 2. So let's look at our original problem. You're going to have 2 over x plus 2 times x minus 2 plus 3 over x plus 2. Now, this is my common denominator, x plus 2, x minus 2. What does this fraction need to be multiplied so that it has the same denominator? It needs to be multiplied by x minus 2 over x minus 2. Now, do you see, if I do that, both of the denominators are going to be x plus 2, x minus 2. Does everyone see that? So I'm only multiplying that second term. I'm multiplying it by 1 in the form of x minus 2 over x minus 2. So what I end up with is I end up with 2 plus 3 times x minus 2, all of that over x plus 2, x minus 2. I add the numerators. Now what do you think I do? Yeah, I'm going to distribute that 3 into the x minus 2. So this is 2 plus 3x minus 6 and so this ends up being what, 3x minus 4? X minus 4 over x plus 2, x minus 2. Okay? So it's the same concept of when you're adding 1/3 and 1/4. Find the common denominator and then add the numerators together. It's just that the denominators are more complicated because instead of numbers, they're variables or expressions. Okay? Now the biggest mistake is you cannot add 2 plus 3 and get 5. You can't do that. The denominators have to be the same before you combine the numerators. So let's look at the next one here. So I hope you see that factoring is probably one of the most critical skills for success in this unit. You've got to be able to factor to combine these effectively. Okay, I've got two fractions that are added together. I just need to figure out now what do I do. Okay, so let's factor completely. If I look at the first one, 3 over, I've got a 10. How can 10 be factored? What is it? 2 times 5. So I've got 2 times 5 times x squared. Now look at the next expression. How can I factor 5x squared minus 10x? Yeah, I can factor out a 5x. And then what am I left with? x minus 2. Okay? So let's figure out what the common denominator is. Every factor you see here has to be represented. Okay? So this tells me I have to have a 2. What other number do I have to have? A 5. Okay? What else do I have to have? X squared. Okay? Now this tells me I have to have a 5. I'm in luck because what? I already have it. This tells me I need an x. I'm in luck because I already wrote down x squared. I've got 2 of them. And then this tells me I need what? X minus 2. So that is my common denominator. Okay? So my common denominator is going to be 10 x squared x minus 2. Okay? So what you do, you break down everything into its unique factors. To find the common denominator, the least common multiple, you have to represent every factor in the denominator. So this is the common denominator. So I'm going to rewrite this expression to where everything gets the common denominator. So I'm going to have 3 divided by 10x squared. Okay. What do I have to multiply 10x squared by to get 10x squared x minus 2? Yeah. So I'm going to multiply this by x minus 2 over x minus 2. And then what do I have to multiply 5x x minus 2 to get 10x squared x minus 2? I had not intended this to be a trick question, but what do you multiply 5x by to get a 10x squared? 2x, okay? So I'm going to multiply this by 2x over 2x, okay? Now check yourself. When I multiply this, I'm going to get 10x squared times x minus 2. When I multiply this, I get 10x squared x minus 2. So I get the common denominator, okay? So this problem becomes 3 times x minus 2 plus 2x times 2x over 10x squared x minus 2. And if I distribute this, I'm going to get 3x minus 6 plus 4x squared, all of that over 10x squared times x minus 2. So I'm going to write it over here where I have a little bit more room. So I've got 4x squared plus 3x minus 6 over 10x squared x minus 2. Now, is that as simple as it gets? We don't really know at this point. Now, the bottom is the denominator is factored. It is possible that the top is not completely factored. How would I know whether or not it's factored? How do I know if it's factored or not? How would I figure this out? Let's try to factor it. See if we can factor this. Are there two numbers that do what? Yeah, are there two numbers that multiply to negative 24 and add to 3? What are the factors of 24? Come on, guys, you know this. It's going to be what? 1 or 24? 2 and 12? 3 and 8? 4 and 6? And then I start to repeat after that. Right. Is there any way to combine those numbers and get a 3? Okay. Yeah, so this does not factor. Now, it is possible that you would have gotten to this step and something would have factored, but in this case, no. So this is as far as this gets. Okay. Pardon me? Yeah. There's nothing you can do. This is fully factored. This is simplified as far as we go. Now, what are the exclusions? X cannot be what? Yeah, X cannot be 2, and X cannot be 0. Okay. When you set X squared equal to 0, that means X is 0. When you set X minus 2 is 0, that means X is equal to 2. Okay. So these are the exclusions for this particular problem. Okay, looking at the next one, I mean, the key is you've got to look at every piece of the fraction, make sure you factor completely, okay? So, numerator on the left, this one's pretty easy. That's completely factored, okay? What about 3x minus 15? How can that be factored? Yeah, factor out of 3, it's 3 times what? Yeah, 3 times x minus 5. Okay, that's completely factored. Minus, look at the numerator. What can be factored out of the numerator in the next one? 2. So that's 2 times what? 2 times x plus 1. Okay. Now look at the next one. This will factor if there are numbers that multiply to negative 5 and add to negative 4. What does that? Yeah, negative 5, positive 1. So this is x minus 5, x plus 1. Okay, now I am completely factored. Okay. Now there's something you see in that right term that looks like it's going to simplify, which is what? What is x plus 1 divided by x plus 1? That is 1. Okay. So that's going to make this problem simpler. Okay. So I'm going to end up with, this is x over 3x minus 5 minus 2 over x minus 5. I try to get in the habit of just using parentheses more often in this unit. It just helps me recognize things are factored. Now, what is the common denominator? 3 times x minus 5. Okay? So the common denominator is going to be 3 times x minus 5. The first term already has my common denominator. So that's x over 3 times x minus 5. And then the next term, it does not have my common denominator. What would I need to multiply to get the common denominator? Yeah, so I'm going to multiply. You keep saying 3, but I know what you mean is, I had a math teacher that was very stickler about you multiply by 1 in the form of 3 over 3. I know that's a lot of words, but I just want to make sure you're not multiplying by 3. You know that you're multiplying by 3 over 3. Okay, so I think you guys have that. So now I'm going to simplify this. So this just becomes x minus 6 over 3, x minus 5. Okay, and that's my final answer. Questions over that? So what are the exclusions here? Yeah, x cannot be what? Yeah, x cannot be 5. And I think, is there one more? Yeah, one more and then we're done. So you should have time to work on the homework there. Now, key to this is going to be you have to do what to make any progress with this guy? You got to be able to factor, okay? So if I look at the first one, how can I factor the first one? Yeah, if I factor out of 5, then I'm left with what? X squared minus 9 minus 2. How can I factor the next one? Yeah, first I can factor out of 4. Let's do that. That's going to make it easier for me. So 4 times x squared plus 6x plus 9. Now, is that completely factored? No. You're going to have to use multiple steps. How does this factor? This is the what? Difference of two squares, okay? And this is a trinomial, a quadratic that I hope will factor. So let's keep factoring here. So I'm going to have 1 over 5. What is that? X minus 3, X plus 3. Okay, that is completely factored. Okay, minus 2 over 4. Now, x squared plus 6x plus 9. We can go off to the side over here. S squared plus 6x plus 9. That will factor if I can find two numbers with what properties? They multiply to 9 and add to 6. What numbers will do that? Yeah, 3 and 3. Okay. So that means this is what? X plus 3, X plus 3. Okay. Now, I can do a little bit more simplification. What is 2 divided by 4? That's just 1/2, right? So I can write this as 1 over 5, x minus 3, x plus 3, minus 1 over 2, x plus 3, x plus 3. That is completely factored. Okay. Now I need to determine what the least common multiple, what the common denominator is. Okay. This tells me my common denominator needs to have what number in it? 5. Okay. It also needs to have an x minus 3. It needs to have an x plus 3. Okay. This tells me my denominator needs to have a what in it? A 2. It needs to have an x plus 3. Well, this is your lucky day. There already is an x plus 3 over here. It needs another x plus 3. So it needs 2 of them. So that is it. That is the common denominator. So the common denominator has to represent one of everything you see here. It needs a 5, an x minus 3, and an x plus 3. It needs a 2. And it needs 2 x plus 3s. It has 2 x plus 3s in it. Okay? That is my common denominator. Okay? So this is what? 10 times x minus 3 times x plus 3 squared. That's my common denominator. Okay, that's a lot of work just to get to the common denominator. Do you think there are places that people make mistakes? Yeah, I mean, one little algebra mistake and you're sort of doomed in this, okay? So you got to be very careful and methodical about what you're doing. So now we rewrite this problem with this common denominator. So everything has to have this denominator. So I've got 1 divided by 5, x plus 3, x minus 3. Now, what do I need to multiply by so that this has this denominator here? It needs a 2 and it needs a what? Another x plus 3. So I've got to multiply by 2 x plus 3 over 2 x plus 3. And then if I look at the rest of this, what do I need to multiply 2x plus 3 squared by to get 10x minus 3, x plus 3 squared? 5x minus 3. Okay, so this has to be multiplied by 5x minus 3 over 5x minus 3. Okay, at this point you can double check yourself. When I multiply this together, I get 10x plus 3 squared x minus 3. Multiply this, 10x plus 3 squared x minus 3. This setup will give me the common denominator. Now it's a matter of just combining everything. So you're going to have 2x plus 3 minus 5x minus 3, all of that over 10x minus 3 x plus 3 squared. And then you distribute and you'll get 2x plus 6 minus 5x plus 15. All of that over 10. X minus 3, x plus 3 squared. And we keep going. What's 2x minus 5x? Two x minus 5x is what? Negative 3x. And then what's 6 plus 15? Plus 21. All of that over 10. X minus 3, x plus 3 squared. Now, is everything completely factored? Yes or no? No. So here's the deal. I always want to double check it because it might simplify. I can factor out on the numerator a negative 3, right? So that's a negative 3, what is it, x minus 7 over 10, x minus 3, x plus 3 squared. Now, I probably would have taken either one of these as a good final answer, because does this, by factoring here, does it let you simplify any further? No. But what if this had been, instead of x minus 7, what if that had been an x minus 3? That would allow us to simplify. So as long as I'm okay with this being the answer as long as going here doesn't simplify it further, okay? So for example, if this had been minus 3x plus a 1, then that would be negative 3, x minus 3, and it would simplify further, okay? So everybody seems a little bit quiet and shell-shocked at this point. You're okay with this? Is this okay? So